So, good evening, everybody. So, let us start our class. Maybe, hopefully, by tonight, I can complete the formal content, and then we can review for the following in the next few classes. We can review whatever content we do have. Okay, before I start classes, there are a few announcements. One is that the last assignment has been extended until tonight. Okay, and regret request has been extended until tomorrow 10 p.m. not 12 p.m. Tomorrow 4/17 10 p.m. Okay, so hopefully I will cover binary search tree okay tonight, and sorry, I asked everybody to come closer so that you can give attention. I believe if you give attention to tonight's class for the next an hour, then you will get at least 10 points. You will get 10 points in your final from tonight's class. Okay, so everybody please give attention. So our main topic is binary search tree, BST. Okay, but in the lecture note, you will see it as not a binary search tree. You will see it as non-linear data structure. Hopefully, yeah, non-linear data structure. So hopefully by this time you understand what are linear data structures. Linear data structure means array list, linked list, stack, and queue. Okay, these are linear data structure. Okay, data are stored on a line. Anyhow, data are stored serially on a line. You know an array. If you I see some images of array, you know that in array all of the elements stay one by one after another, right? And also in linked list, the elements stay one after another. And in stack and queue, the elements stay one after another, so in a line. So we say this is linear data structure. These are linear data structure. But there are other kinds of data structure that are called trees and graphs. Mainly graphs and trees are non-linear data structure. You will know more about this in your advanced level computer science course, mainly data structure course. You will learn more about this. And our goal is to give you some basic idea. So by the time you take your data structure class, once you hear about the basic idea, then maybe some of you will have some chance to do some practice and do some more study. And whenever you hear something, then you may have some opportunities to explore about this. So a graph is like data are put in nodes, but nodes are interconnected. You see that this one is a graph. Node 4 is connected with node 3, 5, and 6. So one of the applications of graph is map. You know, Google and other companies, they have developed maps. that we use on our phone on GPS. So for instance, this is a place, maybe this is a house, or this is another house, this is another house, this is another house. So how can we go from one house to another house? We from place 3 to place 5. So we may go through this direction, 3 to 4, 4 to 5, or we may go this direction, 3 to 2, 2 to 5, or we may go this direction, 3 to 2, 2 to 1, 1 to 5. And one of the important properties of a graph is that is called shortest distance. So you may hear that shortest distance. Sometimes when we travel from one place to another place, we seek for shortest distance, or sometimes we avoid maybe freeway or some accident routes, something, right, or some high traffic route. For instance, if this is my freeway from 2 to 5, this is my freeway, and if I am not comfortable in driving a freeway, then I may avoid freeway, and then I can go from 3 to 2, 2 to 1, 1 to 5. So everybody knows, I believe everybody uses GPS, right? So in GPS, you will see that is the graph is implemented, the map is implemented with graph. So this node may be sometimes unidirectional or bidirectional. Unidirectional means the direction will be one-sided, and bidirectional means direction will be both-sided. So here these are unidirected. So you will learn more about in your data structure class. So this is basic information about graph. There is another data structure. It is called a tree structure. So it's tree, but think about a real tree. In a natural tree, in a natural tree, how can I draw a natural tree? If we search about a tree, okay. So this is a natural tree. This is the root, and these are branches. Root and branches, right? And all the way branch there are where the branches end, the leaves stay there, right? Leaves. So in our tree structure, okay, our tree structure, tree the data structure, is kind of reverse tree. This is like a natural tree. Okay, this is a natural tree, but think about this is a tree structure, but this is a like kind of tree that's upside down. That is a tree structure. Your root will be on the top, and then branches are down. So it's easy to understand this way. So in a tree data structure, there will be a single parent. Okay. And for instance, our previous data structure, this data structure, for instance, this data structure, one node may have multiple parents. For instance, this node 1 is connected with both 5 and 2. So it has at least 2 parents. We can say that it has 2 parents. This node 2 has at least 3 parents, 3, 5, and 1. But in a tree structure, every node has 1 parent. We will see that, okay? But 0 or more children. When there is no child, then we call that as a leaf. And the topmost node is called the root. And a tree can be in array trees, or it can be a binary tree. Binary tree means like this: if a node, if a branch have only two sub branches, okay. So for instance, this is our root, and it has another two branches, these two branches, and here there is another two branches, and there are other two branches, and here these green colors are the leaves. There are no more branches. Okay. So if there are only two, each branch has only two branches, then we call that as a binary tree. Okay, and if there are multiple branches, then we call it n-array trees. The natural trees are in general n-array trees. Each branch has multiple branches, right? Natural tree. But in our data structure tree, if we have binary tree, then we will have only two sub branches. Okay. So our goal is to know about binary search tree. Okay, so binary search tree is a binary tree that has actually three conditions. Okay, but there are two conditions over here. I will add one more condition over here. So okay, binary tree, a binary search tree BST is a binary tree. We know that what is a binary tree. In a binary tree, each branch has two branches. Okay, sub branches, either 0 or 2. Okay, but there are two other conditions that these two conditions. Actually, there are three conditions. One condition maybe is missing over here. I will add up one more condition, and let me explain the binary. Show me the binary tree. This is a BST or binary search tree. Okay, so this is a node. A node can contain any kind of data. A node can contain an integer data, and it can contain an object data. It can contain a string. It can contain a float data, or any kind of data. Okay, so in this simple binary search tree, this node contains only integer type data. So for instance, this is the root node. 15 is our root node. Okay, and this root node has two branches. One branch contains 8 and another branch contains 25. Okay, and this node has another two. Okay, so this node has another two branches. One contains 4, another contains 10. And this node has another branches 2 and 6 with values, right? And these 2 and 6, these are not branch node. Actually, these are leaf. Okay, a leaf does not have any branch. Okay, so 2, 6, 9, 12, 17. These are the ending points. We say this as leaves. But these where there are again branches, then we say is branch or node. Okay, so the binary tree has a condition that, okay, so let me show you, make it side by side. Okay, in order to be a binary search tree, there are three conditions. Okay, A binary tree, the condition start from here. A binary tree consists of two nodes, each of which has two child nodes. Okay, number one, and there are three conditions over here. And all nodes in a binary search tree fulfill the following properties. Number one, descendants to the left have smaller data values than the right node data values. Okay, so if this is our, for instance, this is our root 15, then I'm trying to, okay, this is my node 15. So any value to the, if is it has two nodes, right? 8 and 25. So all left value must be less than its right value. Okay, so right side value and then vice versa, and right side values are greater than left side values. Okay, these are the two conditions. So here you see that 8 is less than 15. Okay, and okay, then 25 is greater than 15, and then 4 is less than 8, and 10 is greater than 8 but less than 25. Okay, and 4, it has two other nodes, 2 and 6. 2 is less than 4. Okay, and but 6 is greater than 4, but this 6 is less than 10. Also, you see, if you look at in this, by this line, if you read aloud, you see that 2, 6, 9, whatever values here, these values are in ascending order. Okay, so by looking these three properties, and there is another one more property that is missing over here. Okay, two nodes cannot have same value. There will not be duplicate in a real BST. There will not be duplicate, no duplicate values. Okay, so all values are distinct values. Okay, then you see that all values 2, 6, whatever these values are, if you read aloud these values, these are you can go smoothly because these are in ascending order, right? And here if it is this is 15, 8, 25, 4, 10, 20, 30, and then 2, 6, 9, 12, 17, 24, 28, 36. Whatever value there are, no matter. But the matter is that you can read aloud smoothly in ascending order. And if there is a break in your read aloud, okay, then you can tell that it is not a BST. Okay, so by looking at tree, now we should understand then whether it is a binary search tree or not. Do you understand how to check whether a tree is binary search tree or not? Who does not understand? You didn't understand? Yes. Only one type of value. You can't have the same type of value. Are you saying? I said there will not be duplicate value. No. Okay. What happens if you was? But then that is not binary search. A binary tree. That may be a binary tree, other kind of tree. So it's just yes. A binary search tree is a special tree. Is a kind of binary tree, definitely a binary tree. There are these three conditions. Okay, another condition is that no two nodes contain same values. Okay, this is another condition. Okay. So a binary search tree is a binary tree that has these three conditions. These are the characteristics of binary search tree. So in your test, if we ask to write you at the 4 or 5 conditions or properties of a binary search tree, you should get your answer from this slide, right? You should extract your answer 5 points from this slide. Okay. So again, so binary search tree is a binary tree that has 2 nodes and it has 3 additional conditions, that every descendant on the left side will have smaller value than the values on the right side, and vice versa, every descendant on the right side will have value than its left descendant. Okay, and no two or more nodes will contain same value. So everybody understand? Okay. So now in the next maybe few minutes we will discuss how to two things. We will discuss tonight how to traverse or travel or loop the nodes of a binary search tree, and later we will understand, when we understand the binary search tree, later we will understand how to implement a binary search tree. The implementation is more like this stack and queue, linked list stack and queue. Okay. Okay, binary search tree actually is a balanced tree. Balanced means you will see that every side has same nodes, like this is a subtree or this is a branch, and this is another branch. Okay, so this branch has how many nodes? And there are same nodes. If every branch has same number of nodes, then it is called a balanced BST. Okay. And mostly sometimes if you have one or two nodes missing for a large tree, then still you will say it's pretty balanced. Or sometimes you can say semi-balanced or mostly balanced or pretty balanced. Okay, traversing is a tree is an important thing that we want to discuss tonight. Again, traversing means how you want to organize or display the values of values of the nodes of a tree. Okay, by the way, that okay, a tree can have any kind of data. A tree can be a tree of names. Okay, some of you have maybe family trees, right? The name of your great grandparents, and then your grandparents, and then your parents, and then your siblings, and then maybe your children. Sometimes some of us maintain family tree, right? Okay, so a family tree may not be a binary search tree. If you have multiple, more than 2 siblings or children or uncles, then it will not be a binary search tree. Okay, that a binary tree can contain any kind of value. So what we are discussing here for our simplicity, we are discussing about a simple binary search tree with integer type of value. So our hope that if we understand with this simple tree, then we will understand any kind of tree. We'll get an idea. Okay, there are three kinds of traversal systems techniques. Okay, first one is called pre-order traversal, another called in-order traversal, another called post-order traversal. Okay, so one thing is the common is that order, the word order. Okay, so by remembering the word order, okay, or by replacing the word order by node, we can remember this technique. Okay, for instance, let me show you in our next slide. We have a tree is here. Okay, everybody see this? So this is a tree. Okay, and we want to display, we want to print, for instance, we want to print the elements of this tree in three different schemes: in order, pre-order, and post-order. Okay, so let us understand only one thing. Once you understand in order, then it will be easier for you to understand post-order and pre-order. Okay, so in your test, if you are given a tree like something like this, and if you are asked to give the output in order, pre-order, or post-order, okay, it should be exactly, you should have write exactly correctly, exactly correct. If you do mistake in one or two numbers, okay, then you will lose some points. Okay, but if you give for the next 5 minutes, if you give attention, then you will not miss any point if you get this question. Okay. Okay, I'm telling you technique. Okay, but before I tell the technique, let me check how many of you are giving attention. Okay, so here in order, for in order traversal is here 2, 4, 6, 8, 2, 4, 6, 8, 9, 10, 12, okay, 15, 17, 20, 24, then 25, 28, 30, 36. Okay, if you know the technique, you don't need to see this line. If you know this technique, you don't need to see this line. Okay. Okay. So that I'm reading aloud. Let me see how many of you can find the technique. I said 2, 4, 6, then 8, then 9, 10, 12. Let me tell it again. 2, 4, 6, 8, 9, 10, 12. Did you find any clue? Did you get any clue? So for in order, the technique is that you will put the parent or parent node in between the two other child nodes, two other children nodes. Okay, so who is the 4 here is the parent or root of 2 and 6, right? So it will in order will start from all the way left. Okay, so it will start from 2, then 2 will come here, then the root will stay in between the two children. What are the children of 4? 2 and 6, right? Okay, so then I will say 2, 4, and 6. Okay, then I am done this sub branch. Then for this sub branch, 8 is the parent, right? So then after 8 we will come here. So then when you say 8, then all the way you have to come all the way 9 again. The 9, then 10 is the middle. Then 12. Then when you are done at this branch, then you will go 15. Then after you go 15, you will come all you will jump all the way to 17. Then 17, 20, 24. Then 25, then all the way, jump all the way to 28. And then 28, and then 30, and then 36. So, let me paste it again. Now let me verify it. 2, 4, 6. You see 2, 4, 6, right? Then 8, 9, 10, 12. You see 8, 9, 10, 12. It is better when last time I had a question like this, I graded like this way. I checked like these three. 2, 4, 6, 8, 9, 10, 12. You see that for in order, this will be in ascending order. If you display in order, then definitely this will be an ascending order. You see that all values are displayed in ascending order. Okay, 2, 4, 6, then 8, 9, 10, 12. 8, 9, 10, 12. Okay, then 15. Okay, then 15. Okay, then 17, 20, 24, 25. 17, 20, 24, 25. And then 28, 30, 36. 28, 30, sorry. 28, 30, 28, 30, 36. Okay, who did not understand? Anyone? Anybody understand the in order technique? Okay, so if you understand in order technique, you have a question? Anyone has any question about in order traversal? In order traversal, your node or parent node will be, whatever you say, node or parent node or root will be in between two children node, okay? Okay, and then pre-order. For pre-order, your node will be first. Okay, so your root will be first. So what is my root here? 15, right? Then I have to go 15. Okay, then 8, then 4, then 2, then 6. Okay, 15, 8, okay, 4 to 6. 15, 8, 4 to 6. Let me go this together. 15, 8, 2, 4, 6. Let me give this one color. So if you understand the technique, then you will not do any mistake. But if you do not understand, I believe last time some people tried to memorize. This is not a thing that you need to memorize. You need to understand, okay? Then what will come next again? The 10, 9, 12. 10, 9, 12. Okay, this is another branch. Okay. Then 25, 20, 17, 24. 25, 20, 17, 24. This is another chunk. And then 30, 28, 36. 30, 28, 36. This is another color. Okay. So, likely the post order. For the post order, your node or root will be the last one. Okay. So here, it will again it will start from the all the way left side. Your 2, 6, 4. 2, 6, 4. This is post order 2, 6, 4 in one group. Okay. then 9, 12, then 10. After that, it will go 8. 9, 12, 10, 8. Okay, after that, you will start 17, 24, 20. This is another. Let me make it different color. Okay, after that I got 28, 36, then 30, 25, and 15. Last, give attention, give focus on this last few things. This is will be one in one chunk. The last one, last few will be in one chunk. 28, 36, 30, 28, 25, and 15. Yes.
Why does it go from the main left branch to the middle of the right branch instead of starting from the right branch?
Okay, our strategy is that every parent will be the ending, right? Okay, then who is parent for this one, for this branch? Yes. Okay. Yeah, no, so 246. Okay, yeah, that's good. Give me a second, please. You understand 246, right? So this part 246 is a branch. Who is this root? No, this branch root is 8. This is a child, single child. Okay, it has root 8. Okay, and it has since it is a branch, it has another branch, similar branch. This is the similar branch. Okay, so you have to come this branch first, and this branch second, and this is your third. Okay, then when you will be done with this branch, then your entire of this thing will be one branch, and your entire of this part will be another branch. And who is the root for these two branches? 15, right? Understand now? So I need to start from here 2, 6, 4, then 9, 12, 10, then 8. Okay, now even still I cannot come to 15 here because I have just done this branch. Then I have to go to this branch, but while I'm jumping to this branch, I have to come all the way in to this branch. So 15, 24, 20, okay, then I'm still cannot read 25. I have to go all the way 28, okay, because this is on branch. And this is another branch. For these two branches, 25 is the root. So this 25 is the root, okay? This 25, or all the way you can put 15 annual. 15 is the the root of all the entire, this is the 15, right? Is the root of entire tree. Okay, so everybody please open your pen and pencil, paper and pencil. I will give you a task, an activity to do some practice with a BST, so that we can I want to make sure that everybody understands this traversal. But before I wrap up, anybody has any question about traversal? You have any question? So everybody understand this? Yes. Okay, thank you. So if you go to my GitHub account, github.com/CSITEd and then if you search for a repository, BST, so I have a project, it's called implement BST. Okay, it is a very small program. The same thing as there is a node class, there is a implement BST, okay, and BST class, and there is an implement BST. This is the main method over here. Okay, this code is same for C# and Java. Okay, there is no big deal. Okay, so I want to open this. Okay. Okay, let's do the first activity by traversal it with the same tree that I discussed. Okay, everybody please write down, and then I need 2 people to volunteer over there. Please go to the board. Okay, who wants to go to the board? And other people write on your paper. Okay, if anyone does not have a pen, pencil, go to the board, please. Who does not have pen and pencil? You? You don't have? Then go to the board. Who else? Who does not have any pen and pencil? You? Okay, go to that board. Okay, let's try with this simple one, then I will give you another one. Okay. Okay, I have one more board. Who else does not have any pen and pencil? Okay, yes, see that one. Write the in order, pre-order, and post-order. Yes, on the board. Write in large font, please, so that I can see. Everybody can see. Okay, you can go to that board. Yes, please. Yeah, write the in order traversal. Okay. Write in order on the left side so that you can write all the numbers in one side. Yes. Yeah, that is a tree. That is a BST. Write the in order traversal output and pre-order. In order first. Yes. Everybody. Okay, can we verify this? Are this okay, Sam? Okay, you please read aloud. Okay, one by one, you read aloud. We will check. Everybody agree? Everybody agrees? In order is nice because it's easiest one, because it is in ascending order. Okay. If there is a break in your recitation, then we would notice that. Okay. Okay. Then the pre-order. You write? Let's see. Okay. 15H4. Okay. 2, 6, 4, 12, 8, 17. 14. Good job. Are you done? Okay. Did you write them? Okay.
8, 4, 2, 6, 10, 9, 12, 25, 27, 24, 30, 28, 30.
I cannot check that way. So if you follow my technique, then that if you read aloud, recite branch by branch, then I can check. Like this way. 15, 8, 4, 2, 6. See that? I started from 15, then 8, 4, 2, and 6, right? Then we'll give a pause. Last time when I checked test exam paper, I went to this way. Yes, yes.
15, 8,
Okay, then give a pause. 15, 8, 4 to 6. Okay, then
10, 9, 12,
10, 9, 12. Okay, that's good.
and 25, 2017,
25, 2017.
and 24,
Yeah, 24. Yes, together. Yeah. 24 is together. Yes.
and 30.
Yes, good job. Okay. Thank you so much. So now, okay. Not done. Now, let me open my program. So if you go to that, that program, implement BST, right? Implement BST. Is implementing BST is not a big deal if you understand implementing a linked list. Okay, it's more similar to that. For our linked list, we will have a node class, and then we can have data. A node can contain data, and it will have two nodes. One is called left, another is right. Okay, and this is the constructor. Okay, and initially the left and right child will be null. Okay, and this is the node class. This node is pretty similar with what? With stack, and at least stack and queue, right? It's something, right? Okay, to discuss this. Okay, then we have our class BST. In this class, we implemented the BST operations. First of all, BST contains, the BST contains a node that is called root, and it has a constructor. Initially, when BST is created, the root will be null, and it is checking empty. with if root equal to null, then it is empty, right? Okay. Then insertion of data is like this way. Okay. So that I will discuss this in your next class, but I am giving you just a heads up that insertion has this code, these lines of codes. Not too bad. By the time you will take your data structure class, you will understand this. Not too bad. Okay. And traversal, for the traversal, okay, you see the traversal for in order, there is a traversal method over here. For traversal in order, you will put the display in between traversal your left node and right node. You will put the print line, print statement in between. This is for traversal in order. For a traversal, now guess that for traversal pre-order, you will print the node first. Then you will print the left node and right node. Okay, and traversal for post order, you will put the print statement all the way in. So for now, we don't need, you will not maybe understand, you will not understand everything, but here you should understand the technique that, okay, for in order, print the node in between left and right nodes. That is the technique we follow, right? For in order, we put the parents node in between two children. Okay, and if you understand just only one thing, one of these, then you should understand others. For in order, you will print your parent node in between the children node, and for pre-order, you will print first, and for post order, you will print this last. So this is my print statement. I will put this statement in between my left in order or this. So this code is not, you see that it is recursion, calling recursive order. So not that too much difficult. Maybe if we spend the class in our next class, then you will understand this. Okay, but and then this is my main method. It says implement BST. This BST method, okay, this will call this program. If you run it, this program will create this BST. So now let us do another activity. Quick activity. It will be quick. Okay. So what will be the in order output of this BST? Who can tell it in one sentence? Means in one breath. Yes. Okay. Okay. I'm not giving you hard time. Sorry to tell it, to loud it, to recite in one breath. Okay, but you can take time. But okay. So now everybody try, please. That's good. In order is easy, right? Because you will see that okay, you can come on. Thank you. So for in order, all the nodes will be displayed in ascending order, right? Serially. So 10, 20, 30, 40, 50, 60, 70. Okay, so then who wants to recite the pre-order? Yes.
30, 60, 70.
I could not catch you. Again, tell me again, please. Pre-order.
40, 20, 10,
Okay.
60, 50, 70.
Yes. Everybody agree? Okay, then who wants to tell me the post order? Did you understand? Okay, post order. Oh, you didn't understand the third one? Okay, let us try. Okay. The third one is the post, right? Then what will be in the post order? Then you will start from 10 all the way end, leftmost side, and then you will put 10, 30, 20. Okay, your parent will be all the way end. Here for the node 20, 10, 20, 10 and 30, who is parent? 20 is parent, right? Okay. So 10, 30, 20. Okay, so this is one branch, and then on the other side branch is 60, 50, 70. So who is the parent over there? 60, right? So 60 will be all the way in, right? So then 50, 70, 60. Right? So I have done this website and this. Okay, let me annotate it. So for this side, 20 is my parent. So I will, for post order, I will do 10, 30, 20. Okay. And for this side, I have 60 as parent. So then I will go for post order 50, 70, and then 60. Then when I'm done these two branches, then 40 is my parent, right? So then all the way and 40 will be going all the way in. So anyone has any question? Okay, there are two prospective questions I discussed in this class. Can anyone recall what are the prospective questions? Possible questions that I discussed in this class? Definitely one of these is to search traversing pre-order and post-order and in order. And another is that I asked a question, what are the like 4 or 5 properties or characteristics of a BST? These are on these slides, right? Which slide is this one? On this slide. So everybody is confident that if you get a question from this, from tonight's class, you will be able to answer correctly. Who is not confident? I wish I could write down your name. Oh, sorry, I did not give that in the sheet, right? Okay, I wish I could write down your name and see that if you do any mistake in this question. Okay. Yes. Okay, everybody, please make sure that you sign on the attendance sheet before you leave. Okay? So I'm almost done. So anybody has any question? Okay, so until these are our formal slides. Okay, official slides, but the implementation thing I added myself. Okay, so okay. You will learn about graph in your data structure class. So this is bound in my in this course. Okay, so in our next class, just I will show you some implementation, okay, of a BST. But if you have the program, now you know where the program is available. So please download this program and make some practice, so that in next class it will be easy for me to cover the implementation of BST, and then we will discuss whatever questions you have. We want to review. We can review from the beginning of the content, okay? Now it is time to evaluate, Okay, maybe from tomorrow you will see the evaluation link. Okay. From the beginning, let me recap. From the beginning of this course, I was going too slow. You remember that? I was going too slow. Maybe some of you are concerned that professor will not be able to finish the course content. Okay, because I intentionally did that. My goal was to build a good foundation. You remember that I discussed polymorphism, inheritance, abstraction, abstract class and interface, and polymorphism again and again. Maybe I can recap that again and again for the next 2 weeks. We have maybe 2 weeks class, or about 2 weeks class, right? We can recap this, but I want to give you some tasks. Okay, starting from the beginning of this course. Study all of the questions from test 1, test 2, and test 3. The final will be cumulative. Okay, study all of the questions from test 1, test 2, and test 3. And if you do not understand anything, or especially you missed something you missed some points in your previous test, give focus on those questions. Okay, there might be some questions from your previous test or similar questions from your previous test. Okay, and whatever you do not understand, bring that here in class. Then we will discuss or we will review those. Okay, so until now, is everybody happy? Okay, if you are not happy, if you need extra time, please send me an email. I can give you one-to-one time. Okay, and when you will get your okay, what is that called? Evaluation. Okay, I hope you will evaluate me positively. Okay, please give me feedback, and whatever positive feedback, I would appreciate that I can make my teaching technique better for the next semester, and also we can make our course better for the next semester. I believe this is better. This semester it was better than the previous semester. We have, especially last semester was the first time. So this time we are pretty organized. Okay. Okay, thank you everybody. Thank you and have a good night.